Hey, what's going on everyone? My name is Tyler and welcome to the channel. Today, we're going to be implementing environments in our custom programming language. So, without further ado, let's just dive on in. So, I'm going to go ahead and create a new environments.ts file inside of our runtime folder. And what we're going to want to do is define a class that's basically going to hold the structure for a scope, aka an environment. So, I'm going to do export defaults class, and we're just going to call it environments, like so. Now, an environment class is going to have a few important things. It's going to need to keep track of a possible parent, right? You can imagine the global scope will have its own environments, and the children will have their own environments, but they still need to reference to the parent. So we're going to do parent is equal to a environments, like so. However, you notice this question mark, which if you're not familiar with TypeScript, this means that this could be undefined. So there might be a parent or there might not. So we're going to define it like that. Then we're going to want to have a way to actually get the variables that are defined in said environments. So I'm going to call this private and then parents, like so. And here we're going to call this variables. And this is going to be a map type, a map of strings to, and we want the runtime values, like so. So let me go ahead and actually define our runtime values type. So I'm going to import runtime val from dot slash, not interpreter, slash dot slash values.ts. And there we go. And the reason we're getting an error is because there's no initializer. So let's go ahead and define a constructor which will take in a possible parents, and we'll say the parent environment is going to be, we'll pass in an environment like so. And what we'll do is we'll just do this dot parents is equal to parent environment. Then we need to do this dot variables is equal to a new map, like so. And there we go. Now we have the place where we can store our link to our parents and the variables that are defined in the scope, which the string will be the identifier and the value that'll be held in runtime will be stored there. Now, in this video, we want to implement the functions for this, so let's define a few functions. First, we're going to want a few public methods. One's going to be declare variable, which is going to take in the var name, which is going to be a string, obviously, and the value, which is going to be a runtime value, like so. And we're also going to return a runtime value as well. Now, to declare a variable, it's pretty simple, but we still want to verify that the variable is not already defined in our current scope. So what we're going to do is we're just going to do if this dot variables dot has our var name, then all we're going to do is we're just going to throw cannot declare variable, and I'm also going to use this as a template string. And we're going to pass in the var name as it's already defined, like so. Okay, so we define the variable. If it's not already defined, then we can go ahead and define it by just doing this dot variables dot set. We pass in the var name and the value, and then we can just return value, so that way this function always returns a value. And there we go. We've already implemented how we can declare a variable that's not already defined. Let's now implement a function that assigns to a variable that has already been declared. So public assign var, it's going to take in var name and the value. And it's also going to return the value that we implemented. Okay, so when we're assigning a variable, it's also very, very simple. We want to basically set the variable, but we also want to make sure that it exists. So what we're going to do is we are going to make the executive decision that if a variable does not exist, kind of like the opposite of here, then we're going to throw an error. However, you could make it that if the variable name is not found, then instead of throwing, what you could do is you could just assign it. But in my decision, I want this to be more explicit for our language, so we're going to say if this dot variables dot oh, wait, there is one thing here. My bad. We are going to create a function called resolve. And this resolve function is going to take in the var name and return an environment. What this is going to do is allow us to traverse the scope of environments to find a variable if we need to assign, right? You can imagine if we're trying to assign x, and x doesn't exist here, but x exists in the global scope. We want to traverse through the parent and get that reference to the variables. So what we're going to do is inside of our resolve function, we're first going to check if our current environment has this. We're going to do if.variables.has var name. Then all we're going to do is we're just going to return this. That's going to return the environments that we're currently in. Then we're going to want to check if this dot parent is undefined. What we're going to want to do is throw an error, and we're going to say cannot resolve, and we're going to pass in the variable name. I also need to do a template string. Cannot resolve var name. I'm going to put this in quotes as it does not exist. There we go. And then if we make it this far, then what we're going to do is we're just going to return this dot parent dot resolve. And we're going to pass in the var name like so. Now what this is going to do is it's going to check if our current scope has it. If it doesn't, and we have a parent, it's going to go to the parent scope and repeat the process. So we don't have to worry if the parent scope doesn't have it, or the global scope at some point doesn't have it, it's going to throw an error. And that's what we're going to do. So when we assign a var, we're going to do const env, because we want to get the environment that the variable might be defined in. And what we're going to do is env equals this dot resolve var name. And then what we're going to do is we're just going to do env dot variables dot set var name is equal to value. And then we're going to return the value like so. So now we have the ability to assign a variable, declare a variable, resolve a variable's scope, right? And now we're just going to implement one last function, which just simply given a string will return the value of this variable. So we're going to do public lookup var, and it's going to take in var name, which is a string, and its return type is going to be a runtime value, like so. And we're just going to do const env is equal to, and we're going to do this dot resolve, because we want to get the location of our variable name. And then we're just going to do return env, env dot variables dot gets, and we're going to pass in var name. Now, the reason this is going to throw an error is because TypeScript has no clue that this might not be undefined. We know it's not going to be undefined. If we pass into resolve this variable name, and we get this value back without throwing an error, then we know for a fact that this is going to return the environment that this exists in. So when we do .get, we know it's never going to return undefined. So what we're going to do is we're just going to do as runtime value, like so. And there we go. Now we have our 4 main methods for interacting with an environment. And these are pretty much the only methods we're going to need for the majority of our interpreter for the environment. So let's minimize these. And let's actually make sure this is exported. It is, and now we can actually use this inside of our interpreter. So I'm going to come in here, and to begin, when we evaluate a program, we want to know the current environment we're currently in. So I'm going to create an environment variable and say it's of type environment. And whenever we pass anything in to evaluate, we're also going to be passing in the environment that's therefore going to have access to the current variables. So whenever we call evaluate, we'll need to pass in an environment. And in here, let me look at all the places that don't have this EMV and pass it in. So we're going to pass in EMV and ENV. Now you notice EMV is not defined in these places. So the good rule of thumb is every single scope of an eval function is going to have this environment passed in like so. So we're going to pass it in right here, ENV. And then up here, we're going to want to pass in the environments. We're going to have to declare the environments as well as the numeric binary expression. For now, we won't need to pass in an environment since we know there's no need for us to evaluate anything, right? The left-hand side and right-hand side have both been evaluated to their lowest forms. So we don't need an environment there. However, we need one here, like so. Okay. So now we passed in an environment to all of our functions that call eval, except our main, right? We need our main function to now pass in an environment. So I'm going to pass in an environment like so. And we're going to create this environment up at the very top level up here. So we're going to do const env is equal to a new environment. And that's going to work just fine. However, we maybe want to pass in global variables, right? So the way languages will want to define global variables is you'll want to define a custom set of variables in your definement, right? So custom set of identifiers and such. So let's now go ahead and actually implement a default parameter that we could pass in to pass in more variables, right? So we can see that we could do environment dot, and we have access to declare var. Let's say we want to declare a variable called x, and we want the type to be a number of 100. So let's do value 100, and the type is number. Now you'll notice this is going to yell at me, right? And number, oh my god, number value, like so. And there we go. Now we've defined a variable x in our environment, just like that. So the last thing we want to be able to do to actually make it so we can access x and work with it is inside of our interpreter, we're going to want to handle numeric literals, we handle null literals, we handle, but we also are going to want to handle the identifiers. So we're going to have case identifier. And what we're going to do is we're going to return a eval in identifier like that. And we're going to pass in the AST node as an identifier. And then we're going to pass in the current environment. And now let's actually go ahead and implement this eval identifier function right here. So we're going to do export, or not export, sorry, function eval identifier is going to take in an ident, which is going to be of type identifier in an environment of type environments. The return type is a runtime value. And what we're going to do is we're just going to simply do const val is equal to, we're going to get access to the currently passed in environment, dots, and we're going to look up the variable var name. So ident dot symbol, which is going to be the string that the identifier has from our AST. And then we're just going to return val, like so. And there we go. Now we actually have all the tools we need to be able to identify and work with variables. So to demonstrate this, since we don't have the ability to assign variables until the next episode, for now, let's try to get access to this x, which we know is a value of 100. And then after we do that, we're going to clean up this right here, so that way this can look a little bit cleaner. So let's actually give this a shot. Let's open up our terminal, clear it out, and do deno run -a in main.ts. If we run the REPL and type in x, we would expect to get a value of 100. And sure enough, we do. We're able to get a value of 100. If we pass in x minus 500 divided by 3, we should expect to get x minus 250. And there we go. Right? So this seems to be working. X plus 500 gives 600. X divided by 2 is 50. And x plus null is, well, null. So this seems to work. Let's also try accessing a variable that doesn't exist, like foo. And we can see uncaught cannot resolve foo as it doesn't exist, which it doesn't. Now, this looks really ugly in my opinion, and I would like to have some kind of macros, I'm going to call them because I'm from C, a macro kind of function that will simply define these types for us. So we're going to call it make number, and we're going to pass in 100, like so. And then I won't need to do this. So then we can, when we declare a variable for testing, we can do this. So let's create a make number function inside of our values.ts. So here we have a type of null and number. I'm actually going to change the way the null type works, so it just holds a null value, the literal null. And for number, we're going to do the same thing. We're going to create a function, we're going to export it, make, and it's going to take in a number. And if we don't pass one in, we'll default to 0, like so. So what we're going to do is we're just going to return a type of number, value of n as number value, like so. And then I'm going to copy this same function for make null val. So it's going to be called make null, like so. It's going to take in a type of null, return a value of null, and this is going to be a null value. And it doesn't need to take in anything. Okay, so now let's fix the main.ts, the interpreter, which has all these values of null. We need to change from, instead of being a string, to, well, an actually thing. Or even better, we could just call return make null everywhere we need to. So return make null, and up top we'll also call return make null. There we go. That simplifies a little bit of our code, and now we can get rid of this null value reference, which is quite nice. Next, in the main.ts, we're going to want to import our make number function, like so. And there we go. Now we have the ability to create a number and such. However, one thing we also want to be able to do is environments.declare things like true to being something like a make bool, as well as a false variable. And we also might want to also have null just be its own custom type, right? So instead of having null be a value that keeps constantly getting returned, maybe what we actually want to do is instead just return a, we actually just want to return a null value instead. So let's actually go ahead and implement this. So to implement the true and the false, we're going to have to create our own custom make bool type. So let's declare a make bool, like so. Cool, that looks beautiful. Now let's go ahead and implement it in our values.ts file. I'm going to create a new type up here called boolean. And what we're going to do is we're going to basically just copy this right here. And instead of null value, this is going to be a bool val. And we'll call it a boolean val. This is going to be of type boolean. And the value is going to be of type boolean. There we go. We're going to have a make bool function, which is going to take in a type of boolean. The value is going to be b, which b is going to be equal to true by default. However, you could pass in something else. And as a boolean value, like so. And there we go. Now we have the ability to create true or false values inside of the runtime. Now there's one last thing that's kind of ugly here. And that's that inside of the environment, or not environment, sorry, the interpreter, we can start looking at where we start running the code, and we have a null literal type, which I don't actually quite like very much. Instead, I would rather us just have null be handled as if it's an identifier, just like true and false currently are. So let's actually get rid of this type right here. And what we actually want to do is get rid of every single reference, basically, to a null type in our front end. So in the AST, we're going to get rid of this null literal, like so. Which means we also have to get rid of it down here. And then inside of the parser, we're going to get rid of all of the references to null literal as well. So that means we're going to have to go down to the primary expression at the very bottom and get rid of the null literal here as well. And that means in the lexer, we no longer need this null type as well. Currently, literal types, there's only going to be one other we'll have to add, and that'll be a string literal, which we're not going to add right now, but this will basically be a string in quotation marks. But for now, that's actually everything we needed to add. We can get rid of this right here, like so. And now, if you wanted to try out this code, it'll actually work the exact same as before, except we'll have 3 new types. We'll have a null type, so we can type null, and we still get the same results as before. It has a type of null. We can type true, has a type of boolean, false, has a type of false, and we can do operations on them. So we can do x plus 45, and we get 145. We can also do x minus true, and we would expect to get null, because you cannot do binary operations with a value like this. So that's really cool. Now we have a very, very basic environment, but we have all the tools we need to now really start pumping out things with our language. In the next episode, we're going to add variable declaration, so it'll allow us to write code like this. Let x equal 45, as well as let foo equals null, something like this. And then we'll actually be able to assign them using x equals 45 plus foo, which we would expect to result in null. So I hope to see you guys in the next video. Until then, I'll talk to you later.